So hi, this is a Great Car Basic demonstration of I2C Discovery. I'm using this as a way of showing the code. It's just a way of showing that you can do this stuff in I2C and that the code is stable. So look what we've got here. So what we've got is a nice little setup. We've got a pick. It's a 1937. That's connected to a bus, and no, this bus here is two wires quite clearly: a data line, a clock line, and in here I've got attached to it a real-time clock, an EEPROM, a serial expander, another serial expander, and a piece of memory. And I've also got a terminal attached to it, which is quite useful because we're going to see what it does. But essentially, I'm just going to show you the code, and then we'll have a quick look at how it works. If we bring up a terminal. This is the PC terminal. There's nothing on the screen, and this is my picket. When I turn the power off, what the code's going to do is actually look through the send out calls onto the I2C bus, and if it gets a response, it will tell us. So let's put it up. It's got a few seconds delay. There we have all my devices. As you can see, serial devices, EEPROM devices, clocks and FRAMs, etc. Now, a FRAM actually shows up as EEPROM, but it's actually got a special port F8 for configuration. So how does it do this? Because it's quite clever. It's got a 2-second delay just to stabilise the power, and job done. How's it doing it? It's using the function calls, and it's just ripping through the 255 potential devices and doing a quick test. Now, I2C start and sends a device ID and a stop. Those are standard in the original code prior to these modifications. But what you've actually got is an end state, which is I2C send state. And if you get an acknowledge back from it, you can actually test against that now. If you get an acknowledge back, you know that that's a live port. So I've got a piece of code that says if that state is equal to an ACK, then I know it's there. If I unplug something, how would I unplug something? I can unplug the FRAM in a moment. Oh, I can unplug a FRAM and a couple of other devices, and that will then it will just show us that it's actually operating. But essentially, I've got a load of cases in here. I can take all these cases out. If I take the cases out, then it will just demonstrate that that these configurations are my configurations, not your configurations. So basically all I'm going to do now is just sample the ports to see if the ports are live, and then I'll unplug something and we'll try it again. But it's really simple. It's start, send the device ID, stop, and test the state, which is I2 send state. There we go. I've got rid of all, because the configuration is my configuration, so it's not valid. So I'm just going to unplug, take off a cable. I just disconnected a clock line. We've lost a FRAM. In actual fact, what we're going to do is I'll just restore that in here, because then I can get my minding gear. We can see what's disappeared. Looks like a FRAM device has disappeared, and a serial expander, which is correct because that's on another board. And put some bolts in it. There we go. We have lost the serial expander because I have taken the clock off. So it's working. It's pretty simple. So the key here is this new code, this new test here, I2C send state, and which responds back with an ACK if it's valid. And you can do this at any time. You can do this at any time during your code. I'll just reconnect that before I forget, because that will just confuse me. Back to the terminal, back to the device, turn it back on. There we go, it's back on because I just took the clock off. Pretty simple, and quick demonstration of I2C Discovery using Great Car Basic. We'll call that a wrap.